Hello everyone, I'm Ashwin Subramaniam from Bachelor of Computer Science, Systems and Networking representing Group 2, and I would like to present about our mini project which will be the topic that we choose is the electricity industry, and the problems will be solar panel, and the solutions, as in the proposal solutions that we are intending to give, will be the dual axis sensor, Internet of Things solar tracker. And my group mates, which will be Valerie, will be presenting for group 2 as well. So as we look into introduction, energy is a form of normal power generation that can be invented and was discovered around 600 BC by the Greeks. And sun-based power, as in solar panel, can now generate energy, and thanks to modern innovation, solar power is the cleanest and plentiful, environmentally friendly power source, and renewable energy is generated from natural resources that will not contaminate the world's resources. Solar thermal and photovoltaic systems are used to convert solar energy into valuable energy. Sunlight-based energy saves both money and energy. Private solar system can save a property owner a significant amount of money over time, and efficient power energy benefits individuals who are in need. The significance of the identified problem for solar panel is it affects the number of customers that use solar energy to generate electricity. The sun moves throughout the day, making conventional PV frameworks less effective at obtaining the correct amount of energy. This affects the customers that use solar energy to generate electricity. For example, as the sun will be rotating around, so it will be less detective for the solar panel to detect the sun rays upon it. Who is affected by this problem? In Malaysia, a lot of people are putting solar powered charger systems in place nationwide to take use of this clean, eco-friendly power supply. As I said, solar power charger systems are actually referring to solar panels. And with solar powered chargers is their inability to obtain optimal energy from conventional PV frameworks. And also, the costliest part of setting up solar chargers is their initial consumption. If limited daylight causes a stir throughout the city, the board's display will suffer. This problem affects businesses and projects that use solar panel to produce electricity, as well as energy producers and utilities that use photovoltaic, sunlight-based and focused innovation to produce power. As we move forward into the impact of identified problem, a farm with a solar panel is used to generate enough electricity to power a large number of homes and businesses. For that, you will roughly need about 2.5 acres of sunlight-based chargers in a bright area to build a solar farm. You need a PV framework to convert solar energy into electrical power, and it struggles to capture the most intense daylight. For example, by these 2.5 acres of sunlight-based chargers, they will be probably producing 1 or 1.5 megawatt of power.
Next, let's look at the current solution. There is no solution for this issue and circumstances. Customers of the solar-powered technology continue to rely on the classic photovoltaic system to generate electricity for their daily needs as well as for conventional contemporary purposes. Since there is currently no solution of this problem, solar panel generates less energy, which lowers their productivity. Moving on, the solution that we have proposed is the dual axis tracking system. This tracker has 2 degrees of freedom, which means it rotates from east to west, north to south. In simple terms, it rotates as left, right, up and down. This means that we do not have to change or adjust anything, as it will move according to the sunlight. This type of tracker can be used for all latitudes, but it is not used for large commercial applications. Now, there is two methods that we need to know. First is the passive and second is the active. For this passive method, the solar tracker is fitted with a bulb of liquid that has a low boiling point. When the sun ray shines on the bulb, the liquid evaporates, causing the imbalance which tilts the solar tracker towards the sun. And for the passive method, the solar tracker uses electric motor or hydraulic cylinders to adjust the position of the tracker. Adding to that, in solar technology, energy from the sun is captured using photovoltaic and converts the solar radiation into electricity. Yet, as the advancement of sensor technology, light sensors is used in the tracker system and it is placed at various locations at the tracker to determine the sun position, which is done by tuning the PV panel using actuators. For example, as we can see the video in the slide, the panel moves according to the flashlight when the flashlight flashes on the panel. Whether it's left or right or up and down, the panel moves according to the light. So this is how the dual axis tracking system works. Next, let's see the SWOT analysis. For this strength, the dual axis tracking system provides constant power output and also provides optimal solution for areas that may hinder the solar productivity, which means that places that does not have proper electricity, this system will help them. And for the developer side, the payback period on investment is lower and there is significant increase in profits during their lifespan. Next, for the weakness, there is higher cost needed compared to a normal solar panel due to complex design that needs a lot of preparation, and not forgetting the high budget for maintenance, especially for the trackers. Next, for the opportunities, there is a high demand in the market as this is a dependable energy. And for the engineers, they have a bright future as there are many job vacancies, especially in the solar maintenance department. And this is also used as the alternative energy source by the local government. And finally, for the threat, as this is a high-tech complex technology, there is a high demand for the complex material too. And there might be conflicts in the existing energy policies as this is a high-tech technology. In conclusion, overall the power that can be supplied from the solar panels. This innovative technology has the most cost-effective performance compared to the other solar panels and has a little modification compared to the single-axis tracker. The installation isn't that costly as it is a smart financial decision. Looking at the designs, we can also see that this technology is flexible and it is better appreciated in the environment as the academic and also the research institution where the software and hardware materials are developed. Solar is easy to use, readily available and inexpensive. That's all from us. Thank you.